Good morning, girls. Today we are going to do lesson number 25, same chapter number 7, matrices. Now, this is the last topic of this chapter, number 7. It is solution of two simultaneous linear equations. You must have done simultaneous linear equations before also, but this time we will find the solution set using matrices. Okay, matrix method. So whatever equations are given to you, we will change them into matrix form and then we'll find the answer solution set. Okay. Okay, now let me tell you the steps which you have to follow. We will find the solution set using matrix method, and the next also second method important one is Cramer's rule. Okay, so first we'll do matrices by matrices and then we'll do the Cramer's rule. Both we are going to do. Let's start with this matrix method, how to change the equation into matrix form. First step is you have to change the linear equation. Okay, linear equation into matrix form. Okay, now let the equations are, let me write the equations first. Okay, and then I'll tell you how to write it in matrix form. Now suppose two equations are ax plus by equals to e, first equation. Then second equation is cx plus dy equals to f. Now these are the two equations. We will write them in matrix form. So how to write these in matrix form? Before equals to sign is ax plus by, so we will write this in the first matrix. Then equals to sign and e and f are constant, we'll write them in the second matrix. Okay, so two matrices you are going to make. In first matrix, before equals to sign, ax plus by, and second row cx plus dy. Then equals to sign, first e and second equals to f. So this way you will write the two equations in the matrix. Before equals to, you will make one matrix, and one is after equals to. After equals to sign, you will write the constant. E and f are a constant. Here variables, two variables are x and y. Okay, coefficient of x is a, coefficient of x is c, coefficient of y is b, and here coefficient of y is d. So variables are only two, x and y, and rest are the coefficients, and after equals to sign is the constant term. Now this is the standard form of the equation. If the equation is not in this form, you will arrange the equation in this form. First you will write x, then you will write y, then equals to constant number. So you have to change it in this form if equation is not in this form. So this is the first step to change the linear equation into matrix form. Now the second step, you will name the matrices. You will separate them. You will separate the variable, you will separate the coefficients, and then name them. Okay, separate them and name them. The second step is Name the matrices. Now how to name the matrices? Okay, let A is in first matrix. You will write coefficient of x in first column. So coefficient of x is A and C. Okay. Second column, don't write plus sign. Second column, coefficient of y, B and D. Okay. First column, coefficient of x, A and C. From here, A and C. Don't write plus sign. Second column, we'll write coefficient of y, B and D. So we have just written the coefficients. We have not written the variables. We have just written the coefficients. So in first matrix you will write the coefficients only. Now second matrix, x, name it x. In second matrix we will write the variables. Okay, so there are two variables, x and y. So you will write it in one column, x and y. Write them in one column, x and y, and then in the end constant, we will write the constant term. Constant is b. b is constant. Okay, constant also you will write in one column, so it is as it is, E and F. Okay, so in the first matrix, name it A. So in A matrix you will write coefficient of x and coefficient of y. There are two columns, coefficient of x first column, coefficient of y second column. Then you will name x to this variable column. In one column you will write x and y. So this matrix, variable matrix, is known as x, and the last matrix is b. In this matrix B you will write the constant numbers. Okay, so let me write it on top so you will remember it. What we have written here, this one is constant. Okay, in the last matrix you have to write constant, and in matrix X you will write the variables only. Okay, variables in matrix X, and in matrix A first column is coefficient of x, short form coefficient of x, and second column coefficient of y. Okay, so I have written this so that you will remember it, how to make these matrices. Now the next step is to apply the formula. We'll write down the formula. Okay. Now the formula is formula. Now in the equation you can see first matrix is A, x equals to B. This matrix is Ax equals to B. So we will write A x equals to B. Ax equals to B. Now in Ax equals to B you can see unknown is xy variables. Xy are unknown. So we will find xy. Okay, matrix X you have to find. Matrix X is unknown. So what we'll do, we'll keep x here, shift A that side. So A is multiplying, after equals to sign you will divide, B divided by A, and shift A up. So what will happen, when A will go up, power plus 1 will change into minus 1. So A minus 1 B. A minus 1 is A inverse. You have already done the formula A inverse, additive inverse in the previous lesson. So you will find additive inverse of A and then multiply by matrix B. So this is the formula which you are going to apply after arranging the after writing them in the matrix form. After writing the equations in matrix form, you will apply this formula. So in this formula, find A inverse, multiplicative inverse first, and you all know that multiplicative inverse is adjoint A divided by A. So apply this formula, okay, find A inverse and then put the value here multiplied by B. Arrange the equations, write them in matrix form, then write this formula x equals to A inverse B. A inverse is adjoint A divided by determinant A. You will find the determinant. If determinant is non-singular, then you will solve it further. Otherwise, no need to solve it further. If it is singular, if determinant A is 0, it means that you cannot find the solution set. Solution set is a null set. Remember this. Solution set is a null set. Okay. Now let's do the example. First example. Okay, now example number 1 from your book. Same example, we'll solve it by Cramer's rule also. First, we are going to solve it by using matrices. Okay. Now you have to find the solution set. So equations are given. First step is to write the equation into matrix form. Okay. So step 1. You have to transform the equations into matrix form. This is the first step. Okay, transform the equation into matrix form. So we will write the equation into matrix form. So there are two equations. So we'll write both. 5x minus 2y and 2x minus y. Before equals to, then equals to 1 and 0. Now we will separate the variables and coefficients. Separate them. Coefficient of x in first column, 5 and 2. Coefficient of y in the second column, minus 2 and minus 1. Now minus sign is given, so you will write minus sign with the elements. Okay. So first column coefficient of x, second column coefficient of y. Now next column you will write xy, two variables, and this last column equals to 1 0 as it is. Now we have changed it into matrix form. After changing them, you have to give them names in the second step. Step 2, name the matrices. Okay, you have to give them name the matrices. You will give the names according to your book. Okay, same, you are going to apply formula, same one. Don't change the alphabets. Okay, so let A is first matrix, 5 minus 2, 2 minus 1, and matrix X is second matrix. Variables are given in which x and y, and last matrix is B. constant matrix is B, 1, 0. Okay, this is a constant matrix. So we have given them name. After giving their name, you have to apply the formula. So therefore, according to this equation is Ax equals to B. So X equals to A inverse B. So this is the formula. So now we'll solve the question according to the formula. So the next step is apply the formula. Okay. Step 3. Step 3, in the formula A inverse, what we do, A inverse is equals to adjoint A divided by determinant A. So we will find determinant A first. Find determinant of A. Okay. After finding determinant A, you will check it if it is possible to solve it further or not. It means that if it is singular or non-singular. Okay, let's find A, determinant of A. So A, matrix A is this matrix is A, 5 minus 2, 2 and minus 1. So let's write the matrix 5 minus 2, 2 and minus 1. So change it into determinant form. Then determinant of A is 5 minus 2, 2 and minus 1. This is determinant. Now find the determinant. You know how to find it. We did it in the previous lesson. Determinant of A is equals to, you cross multiply, right? 5 into minus 1, then minus sign, minus 2 into 2, minus 2 into 2. So 5 into minus 1 is minus 5, minus into minus plus, 2 into 2 is 4. So determinant of A is minus 1. Determinant of A is minus 1. So that it means that it is not equals to 0. So it is not equals to 0. It means A inverse exists. It means that you can solve it further. If your answer here is 0, you simply write the solution set is a null set. You will make the null set in the answer. Okay. Now here, if now it is not equals to 0, so we will solve it further. After finding determinant of A, we will find adjoint A, then put the values in the formula and find A inverse. Okay. Now step number 4 is to find adjoint A. Okay. Step number 4, you have to find adjoint A. Now find adjoint A. So now how you'll find adjoint A? We have done it in multiplicative inverse. That adjoint A equals to, change the place of first and last. So minus 1 will come here, 5 will go down. Change the sign of second and third. So this will become plus 2 and here minus 2, opposite sign. Okay. So this is adjoint A. Now we know the value of A inverse, we know the value of adjoint A, so we will put the values in this formula. A inverse equals to adjoint A divided by determinant A. So adjoint is -1, 2, -2, 5, and determinant A is -1. Okay, simply put the values in the formula. Now this matrix divided by -1 means all these terms divided by -1. Let's divide them. -1 divided by -1, 2 divided by -1, -2 divided by -1, 5 divided by -1. So A inverse is equals to, this minus minus cancelled, 1, this will become -2, this minus minus cancelled, 2, and -5. This is A inverse. Okay. Now the last step is to find x equals to A inverse B. Now we are going to find the variables x and y. So the last step, step number 5, we will apply the formula x equals to A inverse B. Now the x is xy, x and y equals to A inverse is this matrix, 1, -2, 2, -5, and into B, matrix B is constant numbers, so constant is 1 and 0. Now we will multiply these two matrices. You know the multiplication, row into column. So let's multiply row into column. So this row into this column. There is only one column. First element into first, plus sign. Second element into second. Now there is no second row, so you will close this matrix. Now this second row into this column, 2 into 1, plus sign, -5 into 0. Okay, first row with this column, then the second row with this column. Now solve it. 1 into 1 is 1, minus into plus minus, 2 zeros are 0, 2 ones are 2, minus plus minus, 5 into 0 is 0. So the matrix xy is equals to 1 minus 0 1, 2 minus 0 is 2. So these two matrices are equal. It means x equals to 1, y equals to 2. So x equals to 1 and y equals to 2. So the solution set is, in the end you will write this in solution set in the answer. SS means solution set equals to, double brackets, you write curly bracket, then a small bracket. Always write x first and then y. Close the bracket and curly also. So this is the answer. Solution set. This is the answer. Okay. It's not difficult. Just go step by step, follow the steps, then you can find the answer. Now same question, we'll do it with the second method, that is Cramer's rule. Now let's do the Cramer's rule. Now we'll do the Cramer's rule. Same example, we'll solve it. But before starting the example, I'm going to explain you how to write it in determinant form. In Cramer's rule, we write the equation in determinant form. Okay. This is important topic. Okay. So two equations with two variables. Suppose two equations with two variables are a 1x plus b 1y equals to c1. 1 means that this is equation 1. Then this equation 2 is a 2x plus b 2y equals to c2. Okay, these are the two equations, and we will write these two now in determinant form. Okay, same way we will separate the coefficients of x and y. So when we separate the coefficient of x and y, it is known as d. So the determinant of d is equals to coefficient of x is a1, a2. Coefficient of y is b1, b2. So this determinant is known as d. Second determinant is d small x. So dx means we will replace the coefficient of x to find the value of x. So how you will remove the coefficient of x? These two you will remove it. Okay, only coefficient of x. Coefficient of y you will write as it is, b1, b2. Okay, coefficient of y as it is, only you will remove the coefficient of x, and instead of coefficient of x you will write constant c1 and c2. Okay, so instead of this, after finding dx, then you have to find dy. So with the help of this you can find the value of y. Now in case of dy, you will replace the variable of y, coefficient of y. Write the coefficient of x as it is, a1, a2, and in y you will replace the coefficient of y with the constant c1 and c2. Okay, easy it is. In the where x dx, replace the coefficient of x by c1 c2 constant, and in dy replace the coefficient of y with constant c1 c2. Okay, now you are replacing x only here, so write the coefficient of y as it is. You are replacing y here, so you will write x as it is. Okay, in x replace x, in y replace y. Okay, now the last step after this, you will find x and y. So x, how you will find it? X is equals to determinant of x divided by determinant of d, and y is determinant of y divided by determinant of d. Okay, so there are three determinants, d, dx and dy. Okay, in determinant d you will write the coefficient of x in first column and coefficient of y in second column. In dx you will replace x with constant c1 c2 and this as it is. In dy you will replace coefficient of y with c1 c2 and this as it is. Then in the end you will find x by dividing the value of dx by determinant d, and you'll find y by dividing the value of dy by d. Okay, and all the solution is possible if determinant of d is not equals to 0. So you'll find the determinant first and then check it if it is singular and non-singular. If it is singular, then don't solve it further. Write that solution set is null set. If it is not equals to 0, then you will apply the formula dx and dy and then find x and y. Okay, Now let's do the example, that same example which we did it in matrix method. Same example we'll do by Cramer's rule. Okay, it is important, it comes in the exams also in short question answer. Let's do the example. Okay, now the question is apply Cramer's rule to solve the system. Now two equations are given. Okay, now two equations, you will compare it with a1x minus b1y, okay, equals to c1, and this is a2x minus b2y equals to c2. So let's write the values. A1 is 5 and A2 is 2. Coefficient of x is A1, A2. Coefficient of y is B1, B2. So B1 is minus 2. With the sign you'll write. B2 is minus 1. It is understood that the coefficient is 1. Then C1, C2 are the constant numbers after equals to sign. C1 and C2, 1 and 0. Okay. So coefficient of x is a1, a2. Coefficient of y is b1, b2, and the constant is c1, c2. Now we will find the determinant of d first and check if it is possible to solve it further or not. Okay, let's find determinant d. So determinant d is equals to a1, a2 and b1, b2. Put the values. A1 is 5, A2 is 2, B1 is minus 2 and B2 is minus 1. Find the determinant. You all know how to find it. You'll cross multiply, okay, this and this. 5 into minus 1, then minus sign, minus 2 into 2. So this is equals to 5 into minus 1 is minus 5. Then minus into minus plus, 2 into 2 is 4. So determinant of D is equals to minus 1. So this answer is not equals to 0. It is not equals to 0. So the system has unique solution. Okay. The system has unique solution. Okay. Now after finding d, we'll find dx and dy and then we will divide the answers. Okay. Let's find dx and dy. Okay. So for dx equals to, replace the coefficient of x by c1, c2. So c1, c2 and this will remain as it is, b1, b2. Put the values. C1, C2 is 1 and 0 and B1, B2 as it is, minus 2, minus 1. Now find the determinant of it. Okay, let's find the determinant dx. Okay, dx equals to, cross multiply this 1 into minus 1, then minus sign, minus 2 into 0, minus 2 into 0. Solve it, you'll get 1 into 1 minus 1, minus minus plus 0. So dx is minus 1. Okay. Now we will find dy. Okay. Okay, now dy is, replace the coefficient of y. So a1, a2 as it is, a1 a2 as it is. Replace the coefficient of y by constant c1, c2. Put the values 5, 2 as it is, and constant 1 and 0. Now you will find the determinant of y. So dy is 5 into 0, cross multiply, minus sign, 1 into 2. So 5 into 0 is 0, minus 2 ones are 2. So the value of dy is minus 2. Now we know all the values. We will find x and y. So x is equals to dx divided by determinant of d. So dx is minus 1 and determinant of d is also minus 1. So it means x is 1. Okay. Same way we'll find y. Y is dy divided by determinant of d. So dy answer is minus 2 and divided by determinant of d is minus 1. So minus minus cancelled, 2. Value of y is 2. So now we got the answer. Solution set you will write in the end. Solution set is equals to 1 and 2. Always write the value of x first and then y, and in double bracket, okay, curly bracket, and then in small bracket you'll write x and y. This is ordered pair. Okay, I hope you have understood both the methods. uh, Both you are going to practice, anyone can come, but Kramer's rule is most important. Okay, and this is the last topic of this chapter, 7th chapter. Your homework is to do exercise 7.5. Both methods you will apply, question 1 till 10. Okay, solve these, all these, okay, if possible, and do it with both the methods, okay, so that if any of the method comes in the exam, you all should know how to do it. Okay girls, please complete your work, do all the questions. Anything you don't understand, just let me know, ask the questions, just message me. Okay, but please complete it. Okay girls, take care, bye.